everyone, and welcome to Precalculus. Today we are going to start with section 4.3. We'll come back to 4.1 and 4.2 and learn about right triangle trigonometry. So trigonometric functions are functions that define the relationship between the acute angle theta. This little symbol here is pronounced theta. It is Greek. In a triangle, and the ratio of the lengths of the sides of a triangle. So what that means is that if you we're specifically today going to do right triangle trigonometry. So that little symbol right there is what indicates a right angle. And the other angles, we could call it x, but a lot of times we use theta to represent an angle. So there is a definite relationship between how big theta is and how big the side opposite theta is. Think about it this way. If I were to make this theta taller but not change this side over there, as theta becomes bigger, this side has to become bigger. Again, this opposite side has to become bigger. Or maybe you start with the same basic triangle, and this is your theta, and this is your opposite. And maybe you make theta smaller. If theta is smaller, then this opposite side also becomes smaller. And obviously the other side changed too. The hypotenuse changed also. So this is the study of how the angle relates to the sides is what we call trigonometry. So there are names given to all these relationships. Those names, there are 6 of them, are sine, which we do abbreviate as SIN, but we always still pronounce it sine. And sine of theta is just a way of saying the ratio between the side opposite and the hypotenuse. So for example, every 30-degree angle in the world has a ratio of 1 to 2. Its opposite side is 1 and its hypotenuse is 2. It may be 10 and 20. That's a ratio. So trig functions always talk about the ratio between 2 different sides. If I were to make this really, really, really big 30, I could do that. But these would still have a 1 to 2 ratio. And we call that sine. Cosine, we always say cosine, even though we abbreviate it as COS, don't say cos. Right? So cosine of theta is the adjacent side. So adjacent in the word English, so that ADJ, adjacent in English means next to. So if here's your theta, this is the side that is next to the angle. And this one is always the hypotenuse. Hopefully you remember that from geometry. I guess I didn't review that. And then this one's called the opposite. So it's opposite the theta. But the one that we want to deal with the cosine is adjacent over hypotenuse. If you want to talk about opposite over adjacent and how those two are related, then you're going to get tangent. For example, you might know that in an isosceles right triangle, so if this is 1, this is 1. If this is 14, this is 14. They have a 1-to-1 ratio. And what is the measure of the angles in an isosceles right triangle? It's 45 degrees. Because then this one's also 45 degrees, and 45 and 45 and 90 make 180. So tangent of 45 degrees is a 1-to-1 ratio. But people will just say tangent of 45 is 1. But that's what it means. When somebody says tangent of an angle, they're about to tell you the ratio of the two sides that that angle makes. So obviously, if the angle is really small, then the number is going to be really small, because if this is x and this is y, you're going to get a really tiny number. Where if you have a really big angle, then tangent is going to be big, because you're going to be doing x to y again. So sine, cosine, and tangent are the three main ones that we like to use. There is cosecant, secant, and cotangent, and those are the reciprocal ones, which I've written for you on the next page, reciprocal functions. So secant is hypotenuse over opposite, or sorry, cosecant is hypotenuse over opposite. So that's why I put these at the same level. Now, I know you might be thinking, how come they didn't make sine the flip of cosine? That seems like that would make a lot more sense. Sine and cosine are related, but we won't learn that until 4.5. And it does make a ton of sense when you understand it, but we just really can't quite get there yet. And then cosine is the flip of secant. So if you really want to know hypotenuse over adjacent, you could use secant instead. And then tangent and cotangent are, I know that one worked out nice, didn't it? Those are the flip of each other. But can you see why you don't always really need cosecant, secant, and cotangent? Because you have those three ratios, you just have them upside down. So most people really focus on these first three. These are all things you're going to want to write in your appendix. Reciprocal functions. So this is another way of saying what I just said. Instead of telling it to you as sine is opposite over hypotenuse and cosecant is hypotenuse over opposite, you can think of it as sine is the flip of cosecant. Cosine is the flip of secant, and tangent is the flip of cotangent. And the same is true for the other three. All right, let's start in some problems. Lots of introduction there. So I have a right triangle. Right means you do have to make a 90-degree angle. And it said it has sides 4 and 3. So it looks like I made that one a little longer, so I'll put that one as the 4 and this one as the 3. And then it says the angle theta is across from the 4. So I'm going to put it up here. Find the value of sine of theta. So as soon as they ask you for something, you can write down sine of theta is opposite over hypotenuse. They're asking you for the ratio of those two sides. Well, you know that this side is 4. If you knew the length of the hypotenuse, you would have your answer. So in a right triangle, we can use the Pythagorean Theorem, which says that the leg squared plus the leg squared is equal to the hypotenuse squared. You might have learned it as x squared plus y squared is equal to h squared, or a squared plus b squared is equal to c squared, I think is the most famous one. Oops, b squared is equal to c squared. But I really like the person that taught me leg squared plus leg squared is equal to hypotenuse squared. It reminds you that what the picture looks like. So in this case, 4 squared, the order doesn't matter, plus 3 squared is equal to c squared. 16 plus 9 is equal to 25. Well, I'm not going to write that yet. Is equal to c squared. 25 is equal to c squared. And c is equal to 5. It's technically plus or minus 5, but of course we're making a triangle, so we're only going to use the positive answer. This is a famous Pythagorean triple. You might have learned it in geometry. 3, 4, 5 right triangle. And then anything that has the same ratio, a 6, 8, 10, okay? A 9, 12, 15. So sometimes you'll see two of those numbers and it'll help you get the third side without actually doing all this work. There's several Pythagorean triples. As you find them while you're doing your homework, you're welcome to write them down on your appendix. So sine of theta is a ratio of 4 to 5. So I know it seems a little weird. Why would you want to know this? Trig is actually hugely important in all kinds of building, architecture, construction, because that ratio and that angle and the ratio of those sides is intricately related. My husband, in his job as a civil engineer, uses it uses trig all the time. And if we were in school, I'd hand out to you some of his samples of some of his work just so you could see what he does and how he uses trig on a regular basis. So we pronounce the sine of theta is equal to 4 over 5. If you write the answer as 0.8, that's also correct. Number 2, let theta be an acute angle in a right triangle such that the ratio is of sine of theta is equal to 0.6. So they didn't give it to you as a ratio. They gave it to you as a decimal. But remember, that's pronounced, besides 0.6, it's correctly pronounced 6/10, which is the same as 3/5. So I have some kind of theta, and I know that sine of theta is 3/5. Then I know that there's a 3 here and a 5 there, because that's what sine is. Sine is the ratio of the opposite side to the hypotenuse. So we drew the triangle. We're going to use the Pythagorean theorem to find the missing side, although we don't really need to. Hopefully you already have this in your head, 3, 4, 5 right triangle. So I know that this missing side is 4. And then I'm going to find the values of cosine and tangent. So I'm going to write the formulas again. Cosine is the ratio of the adjacent side to the hypotenuse side, and tangent is the ratio of the opposite to the adjacent. If you're in honors, of course, you have to memorize all these. If you're not in honors, you really should still memorize them. If you're going to have to look at your appendix every 30 seconds to get this, it's going to slow you down and probably make it harder to do things later. So adjacent, so this is considered the adjacent side. It's practically touching the angle. It's right next to it, where this is opposite. So 4 over 5. And tangent is opposite over adjacent. Let theta be an acute angle in a right triangle such that tangent of theta is equal to 3. Now remember, it's always a ratio, so just make it a ratio. Find the values of cotangent of theta and secant of theta. So again, I tend to draw my thetas at the bottom. You can draw it anywhere. That's why I made that first example, so it forced it to come out on the top to make me show you that it can be done different ways. But I usually just draw it in the bottom. Tangent is opposite over adjacent. So 3 over 1, which means I drew it badly, right? If I wanted to make it look a little bit more correct, it's probably only 2 to 1. But it's tall, okay? But I'm not going to be grading you on how perfectly you draw it. So I am going to have to use Pythagorean theorem. This is not a known Pythagorean triple, so I kind of go off to the side and do leg squared plus leg squared is equal to the hypotenuse squared. So 1 plus 9 is equal to the hypotenuse squared. 10 is the hypotenuse squared. And again, it should be plus or minus. I just keep saying that so that when we do go back to problems where you need that, you haven't lost that skill. But it's the square root of 10. So cotangent is adjacent over opposite, and secant is the flip. See, I actually don't have it memorized. I think of it as the flip of cosine. So instead of being adjacent over hypotenuse, it's hypotenuse over adjacent. That's how I memorize secant, the flip of cosine. It'll help you in many, many other things. So by theta, adjacent is 1 and opposite is 3. And you actually could have done that without the triangle. If you remember that cotangent is just the flip of tangent, you could have gotten that answer without doing any work at all. But we did need the triangle in order to do secant. Square root of 10 over 1, which of course, like tangent didn't have the over 1. You don't need the over 1. So those are your 2 answers. Number 4, solve for y in the right triangle below. So I am being given the side opposite my angle, so you can call this theta, and I'm being given the hypotenuse. All right, so this is how it's used in the real world. Somebody has a 60-degree angle or wants to make a 60-degree angle, and they say to themselves, all right, well, if this length needs to be 18, how high should I make this? So they can use trig. They can say sine, because that's the one that relates opposite and hypotenuse, sine of 60 degrees is equal to y over 18. Then I'm going to clear my fraction, multiply both sides by 18. And now I'm going to plug it into my calculator. So you guys are very fortunate. When I was growing up, we had to learn how to find trig functions using tables. You know, there were 0, 1 degree, 2 degree, 3 degrees, and then there was sine, cosine, tangent, and you had to go to the back of the book and look up the answer. And of course, if it was 3.8 degrees, that wasn't on there. So you had your 3.8 and your 4, and you had to interpolate, which means to find data in between given data, interpolate in order to find exactly what you needed. I just need you to feel bad for me. I'm old. But you guys live in an entire, and if we were in school, I'd show you my book. It's in the classroom, so I could show you and make you feel sorry for me. But you guys have a calculator. So I am going to stop this video, and I'm going to show you how to do this on your calculator. So the reason I wanted to show this to you on your calculator is because you do have to look at your mode really quick. So next to the blue second button is mode. If I click on mode, if you go down, you'll see radian versus degree. Your calculator defaults to radian. So you do need to go down and work in degrees. And we'll learn radians in a couple classes. So I hit enter, and now I can hit quit, which is second mode again. And I wanted 18. My sine button is right here above the 2 above the 7, sine. And because my calculator is in degree mode, I can literally just type 60. You don't need the little degree symbol and parentheses. And there you go. So just to show you, sine of 60 it's a value. That 0.866 means that every 60-degree triangle in the world, the ratio of the side opposite to the hypotenuse is a ratio of 0.866. And that, having that list of all the different ratios inside your calculator allows you to do these calculations. So the answer is 15.588. I need you to pay special attention to this next one because it's very tricky. When you start off, most people draw a triangle and they say sine of 30. They remember that sine of an angle is the ratio of the opposite side to the hypotenuse. So they label it 1 to 2. But then they see that tangent of 30 is square root of 3 over 3. And tangent is opposite over adjacent. And they go to label opposite square root of 3 over 3, but there's already a 1 there, which is very confusing. So I'm just going to say right now, this is super important, that when you're given 2 trig functions, you only need 1, okay? You only need 1. I'll tell you later why they give you the second one, but just literally ignore it. If you're given 2 trig functions, ignore the second one. Just focus on the first one. Everybody that does it this way is most successful. All right, so I can find the third side. Let's just call it x. X squared plus 1 squared is equal to 2 squared. X squared is equal to, that's 4 minus 1 is 3. X is equal to, technically plus or minus, but we only want to consider the plus answer. So square root of 3. And now it's very easy to find cosine of 30, which is cosine, you may already remember, is adjacent over hypotenuse, so square root of 3 over 2. Now the next one asks you for cotangent of 60. So sometimes that they're asking you for the other angle. Remember, this is a 90, And so these other two add up to 90 because all three angles add up to 180. So this is your 60-degree angle. So cotangent is adjacent over opposite. So from this point of view, from the 60 degrees, 1 is the adjacent, and square root of 3 is the opposite. Okay? So there you go. We did it, and we didn't even use that tangent, did we? All right, now I will tell you why tangent is there. It is correct. There's nothing wrong with it. It's just that they rationalized the denominator, and so it made it look tricky. So if I unrationalize the denominator, square root of 3 over the square root of 3, I'll get the square root of 3 times the square root of 3 is the square root of 9, which is 3. And then the 3's cancel, and I get 1 over the square root of 3. Well, why didn't they just say so? See, if they had left it unrationalized, you actually would have known the third side without using the quadratic formula. You would have said, oh, tangent of 30 is opposite 1 over adjacent. So I find this problem just to be mean because the number of kids that this confuses is tremendous. Even after I give this whole big long explanation of why you should ignore it, somebody is going to get this confused. So 2 trig functions, you only need 1 to get it. The second one would have been helpful, except that they put it in a terrible form. So I'm going to do something I don't normally do on these videos, and that is I'm going to require you to do something on your own, and I'm going to check your answer for it. And that is you're just going to use your calculator to evaluate each function. You are literally going to hit the cosine button and then 16. You don't need the degree button, but you do need to make sure that your calculator is in degrees, which we just did a few minutes ago for problem number 4. So you can do this one, and you can do this one. Now cosecant, there's no button for that. So the only buttons you have are sine, cosine, and tangent. So if you ever need cosecant, you're going to have to be thinking about sine. And if you ever need secant, you're going to have to be thinking about cosine. And for cotangent, you can use the tangent button. So in order to do this, remember from earlier in the hour, we had sine of theta is equal to 1 over cosecant theta. Or if it's easier, or just a different situation, cosecant of theta is 1 over sine of theta. So I can rewrite this. You must rewrite it. There's no button on your calculator for this. Must rewrite as 1 over sine of 29. And now you can do that. You literally just type in 1 over sine of 29. So these 3 answers, when I check your notes, I'm going to be looking to make sure that you got them. But there's no point in my doing that for you. It's super easy. All right, let's move on to word problems. So the angle of the sun varies at noon. You guys know that. Right now it's a really dark time of year, with the smallest angle occurring on December 21st, which is called the winter solstice. Richard lives in Winnipeg, where the angle of the sun at noon on December 21st is 14 degrees. He has solar panels on his roof with the bottom edge of the panels 25 feet above the ground, and he wants to plant a tree 110 feet from the panels. What is the maximum height the tree can attain if it is not to block sunlight to his panels? So here's Richard's house, and on his house he has solar panels. And those panels are 25, remember this is the way we write measurements, 25 feet above the ground. And then we have the sun. I have to use the yellow. Right, so we've got the sun, and it's very low in the sky. So this horizon here, this ray, is going to hit it at 14 degrees. He wants to plant a tree. He does not want his tree to interfere with his solar panel on the lowest time of the year. The rest of the year, it won't matter. It will never go below 14 degrees at noon. So the question is, how high a tree, what is the maximum height the tree can obtain? So when you go to a nursery where you would buy plants and trees and things, they can tell you for every tree you buy approximately how big it's going to grow. Just like this red cedars of California grow hundreds of feet tall, a little pear tree doesn't grow very tall at all, or an apple tree. Most fruit trees are pretty short. And then some coniferous trees can be really tall. So he wants to find a tree that he can plant 110 feet away and not have to worry about it ruining the light that he needs for his solar panels. So because this 14 degrees is measured from the height of the solar panel, we're actually going to do this problem in 2 stages. First, we're going to find this height, and then we're going to be able to add it to the 25 because that's how high that is. So it's much easier to work with the little triangle. So this is also 110 feet, just like it is below it. And we want to know x. So I look at it and I say, well, x is opposite the 14, and the 110 is adjacent. So I look at my list and I realize that that's tangent. So tangent of 14 is opposite over adjacent. And you can go ahead and you can type that into your calculator. So x comes out to be 27.426. But that just represents this little section up here, 27.426. But remember, that solar panel starts at a height of 25. So I can add 25 to that, plus the 25 feet is a total of 52.426 feet. To do this next word problem, you're going to need a definition. The angle of elevation, and then the angle of depression. So the angle of elevation always is from the horizontal, so usually the ground, and then going up somehow into the sky. That's the angle of elevation. The angle of depression, which more people struggle with, is from some kind of upper elevation. So maybe if you're in a helicopter, I know it's a really bad helicopter. If you're in a helicopter, then this would be their horizontal, their horizon. And if they're looking down at something, this would be called the angle of depression. So if you're starting off someplace high and looking down, that's what we call the angle of depression, because normally you would look straight out. So we have, in this case, a problem with an angle of elevation, a 98-foot extension ladder rests on top of a hook and ladder truck with its base 11 feet from the ground. When the angle of elevation is 73 degrees, how high up the building will it reach? So I know that pre-calc isn't everybody's favorite class, but this is it. This is your big moment. You get to have just a tiny bit of fun. Make sure you make your fireman. He's ready to go. Here's one of his ladders on his hook and ladder truck. We need to have some flames coming out of the building. Okay. So he needs his ladder to reach up to the person that's screaming from the top of the building. There we go. All right. So his ladder is 98 feet. And the base of the ladder is 11 feet from the ground. We want to know how high up the building will it reach. Now let's be clear. He's not doing this math before he goes and fights a fire and says, Yeah, it's actually not going to reach that person, so we're not even going to bother to go. No, this would be more like when they're trying to buy a fire truck, somebody needs to figure out how high the ladder is going to reach in order to decide what fire trucks you need for different towns. Some towns have tall buildings, some don't. So it does make a difference which truck you get. Obviously, there's different angles that are safe to put the ladder at. This one rises at an angle of elevation of 73. So just like the one with the sun, this is our horizon at that point, and then this is called the angle of elevation. So in this case, I'm trying to figure out how high it reaches, which is the opposite side, and I have the hypotenuse. So which trig function is that? It's sine. Sine of 73 is equal to the opposite side over the hypotenuse. Again, I'm going to type it into my calculator, sine of 73 times 98, and I get that the height is 93.718. But that's just the height from where the ladder has its base. That ladder base is a good 11 feet off the ground. So I can add 11 to it, and then I can say that it will reach 104.718 feet. Okay, so if you have buildings in your town that are taller than 105 feet, you're definitely going to want to look for a different truck. The altimeter of a jet airplane approaching Chicago O'Hare Airport in Chicago records 5,900 feet as it passes over the Sears Tower. So the altimeter is something that measures altitude or height. At the same time, the angle of depression from the plane to the near end of the runway is 5 degrees. How far is it from the base of the Sears Tower to the end of the runway? So we have our plane. Don't laugh at my drawings. And here we've got the Sears Tower. And the plane is going to go to a runway at O'Hare. So right here, he is 5,900 feet in the sky as he passes over the tower. At the same time, his angle of depression. So remember, whenever you see angle of depression, draw your horizon. Okay, so the pilot is normally looking straight ahead, but then he looks down to see the near end of the runway. That's where he's going to land, and then he's going to go along the runway until he slows down. That angle of depression is 5 degrees. Whenever you make your angle, it should be going from your upper horizon down to whatever you're trying to draw a picture to. Sometimes people accidentally put it here, but it's not. It's from the upper horizon. How far is it from the base of the Sears Tower to the runway? So we're trying to measure this distance right here. So it will be a little easier if I just, obviously this is not as big as it looks like, but just to make my triangle complete, I'm going to put the 5,900 feet right there. So here's the funny thing. This 5,900 feet is not in my triangle. I need a complete triangle. So you have two choices. One is to recognize that the horizon is always perpendicular to the vertical, which means that this is 85 degrees. Well, now you have 5,900, you have your X, and you have your 85 degrees. Another way to do it would be to remember that if you have two parallel lines, the upper horizon and the ground, cut by a transversal, the alternate interior angles are always the same. So this angle is also 5 degrees. That's another way to get an angle inside your triangle. Or some people might have extended it this way and said that this is the 5,900 because it is the same, right? And then they could use this triangle instead. So you have lots of choices on how to do it, and they will all work. So I am going to use this one. And when they say how far is it from to the airport, they do mean from the base, notice. Not like how far down he's going to go, but on the ground. When you hear the pilot say, we're 15 miles away, they're talking about the base distance. So if I use the 85, then I will have opposite over adjacent. So I could use tangent of 85 is equal to opposite over adjacent. If you had used this method and used that 5, then you'd have to say tangent of 5 is equal to opposite over adjacent. Most people don't like that because the x comes out on the bottom and it's confusing. So you always want to think about, you have so many choices in trig. There's 6 different trig functions. You got to find the one that makes your life the easiest. So, oops, I'm going to undo that. I'm going to clear my fraction, multiply both sides by 5,900, and that gives me x is equal to tangent of 85 times 5,900. X is equal to tangent of 85 times 5,900, 67,437.309. We're measuring this in feet. So of course it's huge. It's measured in feet. So in case you're not familiar with the conversion factor, there are 5,280 feet in 1 mile. And that's how you can convert, because now the feet cancel. So if I divide that by 5,280, then I will get 12.772 miles. So in other words, they're about 13 miles from the airport. A passenger in a helicopter shines a light on a car stranded 45 feet from a point just below the helicopter. All right, I'm just warning you now, I'm not really that great at drawing a helicopter, but, you know, this is the only fun I get. So here's my little helicopter pilot. There we go. And I need a car. Stranded. There's the person. Should be in the car, but the car is stranded. And he's going to shine his light down on the car, right? The helicopter is hovering at 85 feet. And the car is stranded 45 feet. Obviously, I didn't draw it to scale. What is the angle of depression? Okay, so again, as soon as you see depression, you need to make your upper horizon. So if this is his upper horizon, this is the angle of depression. This is the theta you're trying to find, which of course isn't in my triangle, so I can just put it in my triangle. If you remember, alternate interior angles have the same value. So if you think about it in terms of a z, if you can make a z in either direction, then you can get your theta. So this is also theta down here. Tangent is my opposite and my adjacent. Hopefully you're getting those down now. Tangent of theta is equal to 85 over 45. So this one's different in that we haven't done one where we need to find the theta. Usually we're finding one of these two values. So I'm going to teach you how to do that on your calculator. If you want the angle and you have the ratio, that's what the inverse tangent button is for. So inverse does the opposite. You might remember that when we had f of x is equal to, let's say, x squared plus 4, and I asked you to find the inverse function, your first step was to switch the x and the y, right? This is y. So you made it x is equal to y squared plus 4, and then you solved for y. That's exactly what we're doing here. I'm switching, because it's an inverse function, I'm switching these two places. So now you can type this into your calculator. And as long as your calculator is in degrees, it'll tell you the correct answer. So inverse tangent of 85 divided by 45, theta comes out to be 62.103 degrees. That's the angle of depression. That's what this angle is when he's looking down. Number 4, a surveyor is standing 115 feet from the base of the Washington Monument. Washington Monument is totally cool, right? Looks like that. He's standing 115 feet away. And he measures the angle to the top as 78.3 degrees. How tall is the Washington Monument? So it is a slanted monument, but of course, if you find out how tall it is, you're going to find its height within the center of the monument. So we want to know its height, and we have this side. Given this angle, the height would be considered opposite, and this side would be considered adjacent. So we're going to use tangent. Tangent of 78.3 degrees is equal to opposite over adjacent. So the height is equal to tangent of 78.3 times 115. The Washington Monument is 555.314 feet high. Number 6, a biologist wants to know the width of a river in order to properly set instruments for studying the pollutants in the water. From point A, the biologist walks downstream and sights to point C, which is on the opposite side of the bank directly across from A. So here's A and here's C. And he could get into a boat with a measuring tape and paddle across, and then he could figure out how wide it is. But if he doesn't have a boat or doesn't feel like swimming with a measuring tape or string in his mouth, instead he walks down to some other point, and that point is 100 feet downstream, and he sights in. So he takes his survey equipment and he sights in, and he realizes that from this sighting, theta is 54 degrees. Can he find the width of the river? Absolutely. So W is across from the 54, so this side is considered opposite, and this side is considered adjacent. Hypotenuse is always the one across from the right angle. So tangent of 54 is equal to opposite over adjacent. So 100 tangent of 54 is equal to W. 100 times tangent of 54 is equal to, W is equal to 137.638. And we didn't do this last time, but we really should. The river is, should answer in a sentence since it's a word problem. The river is 137.638 feet wide. All right, last one. A 12-meter flagpole casts a 12-meter shadow. So here's my flagpole, right? And we have a 12-meter shadow, and I have a 12-meter pole. Find the angle elevation to the sun from the tip of the shadow. So here's the tip of the shadow, and here must be my sun, because my sun is what's making that shadow. It's hitting it just like that. So I want to know theta. So here's another practice for doing it backwards. So again, I have opposite and adjacent, so I'm using tangent. Again, tangent is a very popular one. Is equal to 12 over 12. So whenever you have the ratio and you're trying to find the angle, you have to use that inverse function, second tangent, on your calculator. This is equal to 1, so inverse tangent of 1 is equal to theta. So you can type that into your calculator, and it comes out to exactly 45 degrees. So the angle of elevation to the sun is 45 degrees. All right, good job, everybody. That was a really long lesson. I hope I gave you a good introduction to trigonometry. Have a great day.